Okay, so 2024. This is B2. So you're given this salad packaging box. Nice development question. So the salad box includes a series of plain or flat surfaces and a clear plastic window like that shown, and it says, like, shows the development of a similar one, okay, with a clear window shown. So draw the given surface development of the salad box without the elliptical window. So one thing to note there is that the major axis of the ellipse is kind of in on the thing there a bit. So the major axis is not on the fold line. If you look at the drawing of that here. So that's just one thing to be taken into account. But anyway, so step one is draw the given surface development of the salad box without the elliptical window. Okay, so that's basically 1 and 4, 5, 6 surfaces, and we'll deal then with B and C afterwards. Yeah, we'll deal with B and C afterwards. So having a look at that there, that's our develop view. Basically you're just copying this, so it's 80 and so it's 110 here, and they're symmetrical and so on, so that's 110 and they're 80 and so on. So I'm going to start at the bottom here, I think, not that it matters greatly, and do that. So you'll be able to see the drawing now. I'll just put the drawing out of the way here a bit. So bottom of it is now, oh yeah, and the reason I'm starting with the bottom is because we have these 42 measurements, so we have all these measurements there. So because we don't have a measurement for the sides here yet, so they're 42, 50, 42. So I'll just mark out there 42, and then 50, and another 42. So 42, 50 and 42, and the base of that is 80 by 50, and then it widens out 15 to each side. Okay, so the base of that is 80. And it comes 15 out to each side. So this is one surface. Now I'm going to draw some of this in heavy, but you're probably safer to draw it light, but it's just so people can see it. So that's one sloping surface. Here's the base. symmetrical, so I'll just mark it up there. So that's 3 surfaces done. Now, the 2 side surfaces there, then that is 80. So they're 80, and it's the same arc then for them. So what I'll just do there is get the center of this. So that's the center of this here. That line there is, and I'll just make that a small bit heavier there. So that's the center line coming out here, and I want to go 40 up and 40 down. So those 2 points here, hopefully they're coming out on the camera. They're 40 up and 40 down, and I'll just grab the compass, swing these arcs out, again, I'm just doing that a little bit heavier than I like to, but I want you to be able to see it, and bring that one in, and if everything is accurate they should be level, but I'll just double check it anyway. Okay, yeah, it's perfect. So that there now is 80, and it's on the same it's the same length as the other one, because it needs to be, because when they fold up they go together, so they have to be the same length. So that is sides, so that's 5 and 6 sides. So I can just take the measurement here now, which turns out to be 42. And use the fact that it's symmetrical, and I can just project these across. That there is base, the 4 sloping sides. Just dot this, put a folding line on that, and finally, just put top on that, it's 80 there by 110. So right. So like I said there, we were told we didn't need to do the ellipse in this. Now, then they said RS is the major axis of the elliptical window, P is a point on the curve, find the length of the major axis and draw the curve. So yeah, they do want it, but I think I'll just do it on it. It might be of use to us. So basically, from the fold line, the major axis is up 20 from this folding line. So major axis is up 20 and it's 90 wide, which is 45 to either side. So I'll do that first. Major axis up 20. So it's 45 either side of the center. So here's the center point on the minor axis there as well. Now major axis is 45 to either side. So that's the end points for the major axis. And point P is 35 out on the folding line here. That's a point on the curve. So 35 out on the folding line there. So that's point P. I'll just mark that there. So basically, I'll draw the major circle here. Now, what you need to know here now, it's kind of a junior cert construction there really, and what I would recommend, I suppose, doing is, I'll just stick in a little freehand sketch here. If you sketch a major, a minor, major axis, minor axis. Now the point we have, and then let's say you do a spoke, if you want to call it a spoke, and it's up and across. That's point P. So that's the construction for a point on the curve. So I want to trace this backwards. I want to work backwards from that. So if I come down from P to hit the major circle, join that back to the center, and go across horizontally, that there is a point on the minor axis. So I now know the size of the minor axis, so just set your compass to that distance there, and that is our minor circle. And after that then we're just dividing it up there. I'm not sure spokes is the technical term for it, but it's just a word I would use for it anyway. So, and into major axis and draw the curve. Yeah, so I did say to draw the curve as well. Now I should have been doing two at the time here, top and bottom. It's a bit quicker. So do the horizontals two at the time. Okay, so my points. So that there's the ellipse, and I guess just to be technically correct there, then that line would be gone over here. This is not folding in the clear plastic. Well, I suppose it would be folding in the clear plastic, whether you see it on the clear plastic or not. I guess you would actually, because there is clear plastic there, so I'll just leave it. Thinking aloud there now, but anyway. So, two sides, front, back, base, top, and the ellipse. So that there is the first part done, the development. Then we've got the ellipse put in, and finally on a separate drawing draw the orthographic projections of the salad box when it's assembled. Now it's in the direction of the arrow, so it's looking in with the clear plastic at the front and a plan then underneath. Okay, so what I would do there, I think, is I will try and draw the plan right beside it here, I think. So it's kind of like a translation, really. So if I slide the base over and just draw the base again over there. So the base was 80y, just put it over here. It's just a bit handier if you can fit the whole thing on it. So that's going to be light now, I guess. Maybe some of it can be seen down through the clear plastic. We'll think about it later. So that's the base. Now the question is, there's a very good reason for putting this straight horizontal over here, because when this folds up, and this is important now to understand, when this flap folds up and the side flap surface folds up, that's going to move up in this direction perpendicular to the horizontal trace or the hinge surface or whatever. So it's kind of doing this, it's lifting up, and this is folding in. So both of them are going to come in this direction, telling me that corner is going to be there. So that's where the corner is when they both fold up. And what I would do with that there then is I can just bring that along here, and there's a few ways I could do this. I could take distances, or I could use the angle here as well, because it's going to be at that angle. Now that's the angle of the line of intersection when they fold over. So I could slide that along. My bloody set square's in the way, and I'll just get the 45 instead. So I could use distances, alright, just to simplify this. So look, if I was to measure that there and say, okay, so when that all folds up, it's 15 out and 15 down. So I could do that, or so, and if that's the case, it's a 45-degree angle. Okay, so I could use angles. So that is, but I didn't just guess that. I didn't guess that it was a 45-degree angle. What I did was I folded them up and found this point here, and it appears it didn't need to be 45, but it seems to be working out at 45. So that, and there there 15 out. Now I'm drawing that in heavy. I'll tell you why now in 2 seconds. But there is actually a tiny bit of thought to this. So I think there is, anyway. I risk making a fool of myself here, but I think I'm right. Because when you're looking in here, this has to be drawn so that the ellipse is at the front, and this being the front if you're looking in. So that's why I heavied these in, but this one is going to contain the ellipse going in here and down that surface there. So I'm going to draw the front view next, I think. Draw all the box first, so I'm going to draw the front view next. So just put that up here somewhere. So those 2 points are the base. And that's going to be the top. Now our question is, what is the height of this, or how do you find the height of this? Look, the easiest way to do it is that distance here. This is the true length. Probably shouldn't be drawing on this now. That's not a big deal. It's not a big deal because it's trying to explain where you got it from. So that is the true length of that surface there when it's sloped up. So if I take that and when those sides fold up, it's still got to be that length. So you will find they'll be the same height. So there's our front view. Like that. So it's giving me a height of about 40 there-ish. So front view and top view of the box. So that's all good, I think. So we've got an elevation in the direction of the arrow and a plane projected from the elevation, including our hidden detail. Yeah, but what I'm missing here now is the ellipse. That is the problem. And to go back to what I was saying in the start there, right? The major axis for the ellipse is not, if I was to heavy it in there, but it probably won't come out, but it's not on the fold line, it's in 20 off the fold line. So in 20 off the fold line, so the major axis is in 20 off the folding line. So the major axis would be here. And basically what I'm doing here now is I'm redrawing that ellipse down here, sort of. It's a slight bit more complicated now because of the bend in it. So I'm going to just redraw that ellipse there. So 110 would be 55 for the center. So there's the center of our ellipse. Minor axis would be here. So I don't need to redo the construction of the ellipse because I've already done that. So there is 1 point on the ellipse, the minor axis, and 45 left and right is 2 other points. Okay, so there's the major axis and the minor axis. Now look, you could just draw your circles again, but I'm going to do this using the fact that it's symmetrical and what's called transfer distances. So I've got points that distance left and right of center. So I've got to point that distance left and right, and then up from there I'll just transfer the height. So here's the height above the major axis. It's like I say, you don't have to do it this way now, but it's just there's less drawing on the sheet. Now you can take a load of points then if you wanted. Now the next 2 points then left and right of center, or whatever that distance there is. So left and right. And the heights of them, whatever that is there. Okay, so that's half the ellipse there now. I'll draw that in. That is half the distance. No, oh yeah, no, it's because it's symmetrical. Again, now we'll use the fact that it's symmetrical here. So I'll use some of it anyway. Now if you wanted to be very exact here, I could take the 20 down here, and if I went 20 up the ways here, this would be kind of a good move to do here now. So 20 below, 20 above. So because this is symmetrical, that's where it's going to cross the edge here. So that and that are, that's going to be the end of the ellipse for me. So what I'm going to do there is, just because this is, I'm using axial symmetry I suppose here really, so I'll just say on one of these lines here, I'll use maybe even the dotted line. So just to continue the ellipse on down. Now that's where it goes over the edge here, and the same there, I'll just use one of these lines here to do a symmetry as well. There you go. So right, so that's all the ellipse that's on the flat. That is all the ellipse that's on the flat. But the problem is it's coming down here then onto this sloping back surface here, and that's the tricky bit, how to do that. So I suppose what I'm talking about here really is, it's this section of the ellipse over here now that goes down and underneath. Now look, how would you do that? Like one easy enough way, I suppose, to understand and to do. Just try and get rid of the sunlight's coming in there now. What a nuisance. I hope that's not gone too dark there now, the one time the sun does come out. So I'm going to put an end view here, a little bit of an end view here. So I don't even need all the end view, but so there's the base. Here's the top, and we said there that the height here was 40. So that is the side view of the box. Now there's other ways of doing this. I might talk about them and see how it affects for time there now, but so there's the side view of that. So really this is the edge here that is all happening. So if I was to do this with a colour to help you understand this, if I was to do this with a red biro, just to help you understand how this is, right, the ellipse, that clear section of the ellipse is going from here all the way over to the center. That would be the center axis of the, let's say, the center of the ellipse, and then continues over, and then it's folded down here. So the question is, how far down here does this come? Now the answer is whatever this distance here is. So I'm going to measure that with my compass. That much. So if I was to colour this in red to show you, so look, that there is, if you were to think of it like, not as a clear section I suppose, but as an elliptical sticker, maybe that was put on it, is a better way to thinking about it. So when that folds down, it's here. So look, that's the other end of the minor axis. So what I'm going to have now is a curve coming over and back up to here, but you'd want to find another point or two on it. So what I will do there, I might just use these points here. I think I will, it just makes life easier. So those 2 points there, we know the width they are apart, but they're actually, if I measure that distance, they're actually like 8 below the folding line. 8 below the folding line. So if I come down 8 there, that's where they are. So when I bring that over, they're on that line there, and if I measure how far apart those two were, they are 22 left and right of the center. So that's going to be 22 to the right, 22 to the left, and that there is the ellipse folding off down there. And again, I know that's clear, but I'm gonna put, because there's an angle there, I'm gonna put a line going across there as well, I think. So that's clear, and because that's clear, then I guess you can see down through that clear. So that part of the bottom would be heavy, and that is all heavy there, and this is also heavy until it disappears, just those two edges there, those lines of intersection, and then it's dotted. So let me think about that now. Yeah, I'm going to put that in as heavy, even though it's in clear plastic, and that's heavy down there. So so elevation looking in from there and plan. Okay, so we're not finished, because you're going to be able to see that clear bit on the front surface of this. So I'm going to have just a little bit of an ellipse again going down there. So I'm going to start off the crossover points. I suppose the key points are these 2 points here where it starts, and I can just bring them straight up from plan. So that's starting there. So starting here, I'll just dot them in a bit heavier to help you see it there when you're watching this on whatever device. And finally, now I could use the heights from here. There's a couple of different ways I could have done this now. I could take the heights for them. So the end of the minor axis there is up a height of 28 I'm getting, and the 2 points in between then are a height of 34. So that's one way you could do it. You could go up a height of 28 here and 34, take them across. So the 28 was the bottom of the ellipse there, and the other 2 points then are straight up from here. Okay, that's one way I could have done it. Now another way is you could project them over to the line of intersection here, to the edge. So when I bring that over to this point here on the edge, if I bring that up here then to the, if I project that up there to the side of this here, it's just hitting here, and then you can go back across and you'll see that it's giving you the same point. And it would be the same with the intermediate one there. You'd run it over to the edge, which is here, bring that up and then back across, and it'll give you the same thing as well. So I'll just finish that off there now. So that's the clear section of the ellipse coming down there from the front. That part there. So yeah, nice question, really nice question. Now I have to say, I think that's right. So just when you're finished, then go back and check over it there. So I had said that I was going to leave them because that was folding all the ways across the clear ellipse as well. And do you see fold lines on a clear plastic surface? That could be debatable, but anyway. And so the front view is okay, hidden detail, yeah. And finally, you should always look back over this, because I was after leaving that out now, is that dotted edge here. And there I hadn't heavied in, and that's dotted down to there, and yeah, so I think that is it there now. So yep. Best of luck with that.